Alright, welcome everyone. I just wanted to talk to you a little bit about special right triangles. We're talking about 30, 60, 90 right triangles and uh, 45, 45, 90 right triangles. It's 30. But before we get to that, let's go over some of the basics of operations with radicals. For example, square root of 3 times square root of 3. Well, when you get a square root of 2 times square root of 3, you get to square root of 9. You're able to multiply the numbers that are both under the radical symbol. That's called the radicand. And the square root of 9, when you do a square root, that means the number times itself that gives you this radicand, which is 3. Okay, so square root of 4 times square root of 4 is square root of 16. What number times itself that gives you 16 is 4. Square root of 5 times square root of 5 is square root of 25. The number times itself that gives you 25 is 5. Okay, and so on and so forth. Okay, I could pick any number out of a hat, like square root of 18 times square root of 18. Doesn't matter what this is. The number times itself to gives you 18, or whatever this thing is going to be 18. Maybe you recognize the pattern here. Maybe I go back to a smaller number. Square root of 9, square root of 9, square root of 81. What number times itself that gives you 81 is 9. Notice how this is this. If you see square root times itself, then it's going to be a regular number without a square root. Okay, so you need to get used to this fact. So maybe I'll pick some huge number out the top of, out of a hat, and I times it by the same thing, 10,128. I don't know what this is, square root of whatever that is, but I know that when I actually do the square root of this, it should be the regular 10,128 without a square root. Okay, so recognize that this number is different than square root 6. Regular 6 is a completely different number than square root 6. Okay, regular 4 is a completely different number than square root 4. Square root of 4 is just 2. Okay, these are two different numbers, but when you see the square root of something times by itself, it cancels the square root out basically and kind of makes it a regular number. Okay, so hopefully that helps you out a bit. Let's talk a little bit about operations when they're different numbers. So square root of 3 times square root of 2, you can still multiply those things on the inside just like we did over here. Multiply those two and get 9. Well, we get the same idea, square root of 6. And that can't be simplified. There are some ways to simplify some stuff in square roots. I'm not going to get too much into them. Okay, but here's some examples of stuff that's not the same number. It gives you something under a square root. You can't really do anything else with it. What square root of, maybe like the square root of, I don't know, 6 is square root of 12. And this one actually can be broken down, but once again, we're not going to get too much into it. If you're really curious, you might have learned this in a previous class, but square root of 6 breaks down into square root of 2 and square root of 3. And once again, there's square root of 2, square root of 2. That makes a regular 2. So this and this are the same idea. It's like simplifying a fraction. You can simplify this radical and get 2 square root of 3. I'm not going to worry too much about that right now. I just want you to recognize that when you multiply something times another number and they're both under square roots, then you get that result under a square root. So what happens when they're not both under a square root? Well, 8 times 2, just like you've done most of your life, is 16. 16 square root of 3. Or what about 4 times 2 square root of 5? Well, this is 4 times 2, which is 8 square root of 5. Okay, how about like 5 times 3 times square root of 5? Well, these things are, one's under square root, one's not. These two things are both not under square root. You can multiply those together. Square root of 5, 5 times 3, 15, and then you get square root of 5. Okay, what about 10 times 2 times square root of 3? Well, this is 20 square root of 3. Okay, start thinking about it. Don't just watch me do it. Think ahead. Give you a little second here. How about 5 times 4 square root of 6? What's that going to be? Should be 20 square root of 6. Okay, kind of getting the idea? Okay, and then the last situation is what happens when some are under square root and some are not. So let's say like this times 3 times square root of 2. Well, these two numbers get multiplied together, makes 16. These two numbers get multiplied together, that makes the square root of 6. There's your answer, 16 square root of 6. Or what if you had like 3 square root of 2 times 4 square root of 3? Well, the 3 and the 4 gets multiplied together, it gives you 12. And the square root of 2 times square root of 3 makes square root of 6. Okay, so if they're both under a square root multiplying together, they're both not under a square root multiplying together. Let me give you another example. How about 4 square root of 5 and 6 square root of 2? Think about that. What's the answer for that? Well, 4 square root of 6 makes 24. Square root of 5 times square root of 2 makes square root of 10. Okay? Now sometimes you'll see stuff where it'll repeat. So like 5 times the square root of 3 times 2 times the square root of 3. Well, as we established earlier, 5 times the regular 2 makes 10. Square root of 3 times square root of 3 is square root of 9. But square root of 9 is just a regular 3. Remember when these repeat, it just makes it a regular number. So then you got 10 times 3, which is 30. Okay, if you want to write this step in there, you 10 times square root of 9, 10 times 3. Okay, and you get 30. Or how about 4 square root of 2 times 8 square root of 2? Think about that for a second. Well, 4 times 8 makes 32. Square root of 2 times square root of 2 is a regular 2. The answer is 64. How about 2 square root of 2 times 4 square root of 2? A little bit easier. Well, 2 times the 4 makes 8. Square root of 2 makes a regular 2. That's 16. Okay, so hopefully you're starting to get the hang of that. That's some of the basics before we're actually able to move on to the actual special right triangle stuff. So there's two types. The first one is called a 45, 45, 90. That's because the angles in the corners are 45 degrees, and then you got 90 degrees. Okay, this is an isosceles right triangle. Isosceles means the two sides, the two legs, I should specify. Legs touch the right angle. This touches the right angle right here, right here. The two legs are, whoops, are the same if it's isosceles. And we know they're the same because the angles across from the side, this one, and this angle across from this side, are the same angles. If you got the same angles, then the sides across from them must also be the same. Okay? Isosceles right triangle. So if this one, whatever this measurement is, this has got to be the same here. And then what we're going to learn is that you could take that leg and times it by the square root of 2 to get the hypotenuse. I can go into a long reason why, but for the purposes of this and to save some time, we're just going to talk about how you use it. Okay, so if this was 10, for example, then this would also be 10, and the answer for the hypotenuse would be 10 square root of 2. And that's it. You don't have to break this down and tell me a decimal actually is preferred. You don't do the decimal. We want what we call exact, where you don't try to give me the decimal. Don't do 10 times the square root of 2. It'll be some kind of long, what we call irrational number. It goes on forever and ever. There's the square root of 2. It's 1.4142. It keeps going on. If you times that by 10, then this number, and this keeps going on forever. This is just as far as it shows on the screen, but it'll keep going on forever and ever. Okay, we don't want that. We want this number. It's exact. That's a better answer for our purposes. Okay, so what you need to understand is that the two legs are the same, and whatever the leg is, you can times it by the square root of 2 to get the hypotenuse. So a lot of times you might see it written in textbooks where they call the ratio of the three sides 1 to 1 to 1 square root of 2. Sometimes they just say square root of 2. They won't put the 1 in front of it, but 1 to 1 square root of 2. It's in that order. 1, 1 square root of 1 square root of 2. Okay, so ratios, you can multiply something. You're going to multiply the whole shape by its number. So let's say we times it by 2. Then this would be 2, 2, and this would be 2 square root of 2. We talked about a multiply 2 times the square root of 2. Or maybe multiply by 3. And so this would be 3. This thing gets multiplied by 3. You get 3 square root of 2. Okay, so that's how that could work. That's one way to think of it. I'm going to give you some other ways. Okay, I have always taught for years where I just call this thing the leg. And this one's also the leg. And whatever the leg is times about a square root of 2. Okay, the two legs are the same in a 45, 45, 90. So let me give you a few examples. Let's say that this is, whoa, don't know where that came from. Sorry. Hang on a second. Let me fix that. Okay, so we're going to continue as if all of these shapes down here are 45, 45, 90. I'm just not going to draw it on all of them. So each one of these corners is 45 and 45 and 90. Okay, let's do a bunch of examples. So if this is a leg, we know the two legs should be the same. So how much should this one be? Hopefully you said it should be 10, which is right. And then we would take whatever the leg is and put it square root 2 to get the hypotenuse. Likewise, this is a leg, then this one should be 5. Two sides that touch the right angle are the same. This side and this side. And whatever the leg is, you take it times square root of 2 and you get the hypotenuse. So this is square root of 2 right here. So this one should also be square root of 2. So now we take the leg, which is square root of 2, times square root of 2. Well, let's clean this up a bit. Square root of 2 times square root of 2, as we talked about earlier, is square root of 4. Like right here. We talked about this idea. And if you see it repeating, that means it's just going to be a regular 2. There's your answer. That's the best answer. Okay? So a whole number 2. Square root of 3 is this leg. That means this leg should also be square root of 3. What's the hypotenuse going to be? Well, you take the leg times the square root of 2. And because these are different, we can actually but they're both under square root, we can multiply them together, you get the answer of square root of 6. Okay, likewise, once again, this leg should be the same as this leg. Should be square root of 5. Okay, think ahead. What do you think the hypotenuse is going to be? You take the leg times the square root of 2. The answer here is the square root of 10. We can't clean that up anymore. Okay. You punch that in and it'll give you some long decimal. We don't want to go for that. These legs should be the same. So this is the same as this one. And a 45, 45, 90. Once again, we're assuming this is 45, 45, 90. And how do you figure out what the hypotenuse is? Well, whatever the leg is, 3 square root of 2 gets timed by the square root of 2 to get the hypotenuse. But this we already established is a regular 2. So it's 3 times a regular 2, which is 6. This is this idea up here. Go back and review it if you need to. Okay, you can multiply the numbers outside the square roots. I'm sorry, that's not multiplying. That's multiplying the numbers that are both under a square root, which makes a regular 2. Alright, continuing. So let's say this is the leg 8 square root of 2. That means this leg should also be 8 square root of 2. How do you get the hypotenuse? 8 square root of 2 times the square root of 2. But, as we figured out earlier, square root of 2 times square root of 2 is a regular 2. So now this is 8 times a regular 2. The answer should be 16. Okay, look ahead. The next one. This leg is 4 square root of 3. This leg is 4 square root of 3. How do you get the hypotenuse? 4 square root of 3 times the square root of 2. Whatever the leg is, you would times it by the square root of 2. Excuse me. So this means this is 4 times the square root of 6. We can't clean that up anymore. That's the best answer. Okay, here's a leg again. 10 square root of 5. Here's another one. 10 square root of 5. Sorry, that's kind of sloppy. But we take the 10 square root of 5 and times it by the square root of 2. These can be multiplied together to give you square root of 10. So it's 10 square root of 10. There's your answer. Okay, so most people don't have as much trouble when you are given the legs. It's when you're given the hypotenuse. You can kind of work backwards. So it's the hypotenuse is whatever the leg was times by the square root of 2. We set it up here. Okay, or whatever the leg is, we don't know it, and then be times by the square root of 2. So if I work your way backwards, you're trying to figure out what is the leg. So something times by the square root of 2 ended up being 3 square root of 2. Now this isn't a terribly difficult question, hopefully, but that something is right there in front. Something times the square root of 2, well, those happen to be the same. Okay, if you wanted to think about solving an equation, which is one way to kind of handle this, you want to get the x by itself, we would divide by the number next to it, because these are being multiplied. Undo with division. You do it on one side, you got to do it on the other side. Those two cancel out. The only thing you'd have left is x equals 3. If you want to do it that way, to me that makes a little bit more work, instead of just trying to figure out what's the leg. So these are the legs, 3, 3, the leg times the square root of 2. Okay, same idea here. Something times the square root of 2 gives you the hypotenuse. The leg times the square root of 2 gives you the hypotenuse, so the leg has to be 4. So this is 4 and this is 4. Think about it again. Something, whatever the leg is, times the square root of 2 is the hypotenuse. And the hypotenuse ends up being this. So if you remember the rules we talked about earlier, something times the square root of 2 that makes the square root of 6, you can kind of just think about it. And what times the square root of 2 would make square root of 6? It has to be a square root of 3. If you don't like that method doesn't make as much sense to you, then you can make yourself a little equation like I did. So whatever the leg is times the square root of 2 equals square root of 6. And we can work backwards, dividing by the square root of 2, dividing by the square root of 2. These cancel out. Some scientific calculators will do this work right here, or you can just learn how to do it yourself. Because they're both under square root, you can divide both of them. Okay, square root of 6 divided by square root of 2 makes square root of 3. 6 divided by 2 is 3. Okay, now I think that is a little bit more difficult, but some people like this method. So once again, something times the square root of 2 will make the hypotenuse, which is square root of 10. Can you just look at that and figure it out? Or maybe you gotta undo the multiplication with division. For some people that works better. These cancel out. This gives you square root of 5. Okay, same idea here. Something times square root of 2 makes square root of 12. This is how you get the hypotenuse. Well, in this case, we got to divide by the square root of 2 to get that to cancel out. Square root of 12, square root of 2, they divide and gives you square root of 6. This answer is square root of 6, square root of 6. Once again, square root of 7, square root of 7. Okay, does that make some sense to you? Hopefully it does. All right, now this is a whole number. That becomes a little bit more challenging. Something times square root of 2 makes a square root, makes a regular 10. I'm sorry, a regular 10. So the square root went away. How do we make a square root go away? Is if a number gets multiplied by itself, if they both have a square root, then it makes a regular number. Remember up here when we talked about it? This section? You multiply by itself, then it makes a regular number without a square root. So how do we make this regular 2? And then eventually get to a 10? Well, in somewhere we have to have a square root of 2. Square root of 2 times square root of 2 makes regular 2. So now it's just a matter of, okay, what times 2 makes 10? And hopefully you guys are looking at this and you're saying, oh, well, 5 times 2 makes 10. So this has to be a 5. Okay? So if that's a 5, then the answer is 5 square root of 2 times square root of 2 makes 10. This is the hypotenuse. I'm sorry, not the hypotenuse. This is the leg. A leg times square root of 2 makes the hypotenuse. Now that tends to cause a lot of problems. The answer is 5 square root of 2, 5 square root of 2. So I'm going to try it again. Something times square root of 2 makes 12. This does not have a square root in it. So that means I had to have a square root in here to get this to be a regular 2. Oh, what makes 12? What times 2 makes 12? That has to be 6. So this has to be 6. So 6 square root of 2 times square root of 2 makes 12. You knew this is a regular 2. Talked about it earlier. So 6 times 2 makes 12. Okay, and with all that logic, this makes the same idea would happen on this last one, but I'll show you another way, because some people really struggle with this. If you don't know what this something is, you know that the leg, the unknown amount, the leg, times the square root of 2 will give you the hypotenuse, which in this case is 14. Okay, so if we work backwards, and we would do we'll be dividing by the square root of 2 to make that go away. We do it on both sides. Now here's the problem, is we can't leave our answer with a square root of 2 in the denominator. For some reason, math people don't like square root of 2 or square roots in denominators. So we got to do something called rationalizing denominator. We take this and you times it by the number 1. Remember, 1 is anything over itself. I chose the square root of 2 because when you multiply fractions straight across, you'd get a regular 2 here on the denominator. So now it no longer has a square root. And then the top will be 14 square root of 2. 14 divided by the 2 makes 7. So the answer is 7 square root of 2. Now to me this seems like a much longer complicated way, but I know that some teachers teach this and Some students like that step-by-step method. 7 square root of 2. This is 7 square root of 2. And so if you took this leg times the square root of 2, then you would get 14. So 7 square root of 2 times square root of 2, that's the leg, and you get 14. Okay, that's a regular 2. Okay, but for me, that seems like a lot of work. But hey, you do whatever floats you. All right, since this video is getting a little bit long, I'm going to stop with the 45, 45, 90, and I'll make a second video that does the 30, 60, 90. Okay, so review this basics. We'll apply the basics again on the second video with the 30, 60, 90s. Okay, all right.